In the previous video, we have discussed how the Earth may be considered at the center of a celestial sphere on which all the constellations are painted like tiny dots. We will now introduce the Sun in our discussion. Clearly, this is not a representative image of what we see when the Sun is up. This is because the Sun is so bright that we cannot see the celestial sphere in the background. We can only observe the faint light of stars when it is dark outside. So we have the Earth rotating on its axis, and the Sun, both at the center of an infinitely far celestial sphere, since we can only observe the stars when it is dark. On any particular day, only a portion of the celestial sphere can be seen from Earth. From one day to the next, this portion does not change very much. However, as the Earth orbits around the Sun over a period of a year, we get to observe different portions of the celestial sphere. When we look at the Sun from Earth, it is against a background of stars on the celestial sphere. Given the brightness of the Sun, we may not be able to observe these background stars directly, but we can deduce what they are based on observations of stars visible on the dark side of the Earth. The constellations appearing behind the Sun will vary constantly over a period of 1 year. Let us go back to our previous image of the celestial equator viewed from Earth. To eliminate the effect of Earth's rotation, we will observe the position of the Sun with respect to constellations in the background every day when the Sun is at its highest point in the sky. We will do this for a period of 1 year. The orange dots show the position of the Sun every day. Let us first do a rapid survey of the results. As Earth orbits the Sun, the latter appear to move above and below the celestial equator, visiting various constellations in the process. We will start our journey with the Sun crossing the celestial equator from the south to the north hemisphere, while in the Pisces constellation. This occurs around the 20th or 21st of March, and is called the vernal, or spring, equinox. It marks the beginning of spring in the northern hemisphere. This point is important, as it defines the 0 point on the celestial equator, from which we can calculate the celestial equivalent of longitude, called the right ascension. The right ascension is not given in degrees, but in hours. It goes from 0 to 24 hours around the celestial sphere. This point on the celestial equator has a right ascension of 0 hour and a declination of 0 degree. We can now use this system to give a position of any star in the sky. For the next 3 months, the Sun continues to climb further above the celestial equator, traversing the Aries and Taurus constellations. It reaches its highest point in the Gemini constellation around the 21st of June. This is the summer solstice, marking the beginning of summer in the North Hemisphere. At this point, the declination is 23.5 degrees, whereas the right ascension is 6 hours. In the following 3 months, the Sun appears to travel through the constellations of Cancer and Leo, to finally reach the equator once again, in the constellation of Virgo. This happens around the 22nd of September. This is the autumnal equinox, marking the beginning of fall in the North Hemisphere. At this point, the declination is 0 degree, whereas the right ascension is 12 hours. The Sun now enters the constellations of the South Celestial Hemisphere. It traverses Libra and Scorpius, and reaches its most southern location in the constellation of Sagittarius around the 22nd of December. This is the winter solstice, marking the beginning of winter in the North Hemisphere. At this point, the declination is minus 23.5 degrees, whereas the right ascension is 18 hours. The Sun then traverses the constellations of Capricornus and Aquarius, before returning to its original location in the constellation of Pisces. The 12 constellations traversed by the Sun over a period of a year make up what is called the zodiac. Let us cheat and look at a simplified view from the outside of the celestial sphere at the level of the celestial equator. We see that the celestial equator, and the apparent path followed by the Sun over a period of a year, form two circles tilted 23.5 degrees from each other. Since the celestial equator is a projection of Earth's equator, and the apparent path followed by the Sun among the stars is really a representation of the Earth's orbit around the Sun, we conclude that the plane of rotation of the Earth differs from the plane of its orbit around the Sun by around 23.5 degrees. The plane of the orbit of the Earth around the Sun is called the ecliptic. Here we show the Earth on its orbit, with the North Pole constantly pointing up, toward Polaris. As the Earth revolves around the Sun in the plane of the ecliptic, different latitudes on the planet receive more light than others. This results in the succession of seasons over the year. This effect is best seen by placing a camera on the Sun, looking at the Earth as it orbits around it. The center of the Earth is positioned on one of the orange points representing the orbit. The red point in the center of the view represents the latitude on the surface of the Earth that is the closest to the Sun at any point during the year. It is on a line between the center of the Earth and the Sun. People standing at this latitude on that day will see the Sun at its highest point, right above their head. We start our journey on the day of the vernal equinox, in March, where the equator is closest to the Sun. As we move toward summer in the North Hemisphere, we see that this hemisphere appears to tilt toward the Sun, so that more light is shed on it than on the South Hemisphere. The maximum tilt toward the Sun occurs at the summer solstice in June, when the Sun is aligned with the Tropic of Cancer, shown in blue. Further north, the Sun will never appear directly above our heads, but will instead appear somewhere south of our position. In the next 3 months, the apparent tilt of the Earth toward the Sun is reduced until we reach again the equator. This is the autumnal equinox. From this point, and for the next 3 months, the north hemisphere of the Earth appears to start tilting away from the Sun, exposing the southern hemisphere to more sunlight, until a maximum is reached at the winter solstice in December, where the Sun is aligned with the Tropic of Capricorn. Further south, the Sun will never appear directly above our heads, but will instead appear somewhere north of our position. Finally, from December to March, the Earth returns to its initial position.